Scattered across the farthest corners of the Earth, remote research stations push the boundaries of human exploration and scientific discovery. From icy outposts in Antarctica to isolated islands and deserts, these facilities allow scientists to study the planet in some of its most extreme environments. Stay with me, I'm going to explore 15 of the most remote research stations in the world, starting with number 15, the Concordia Research Station in Antarctica. The Concordia Research Station, which is on the Antarctic Plateau, is operated as a joint project between France and Italy. It's at Dome C, which is a high-altitude, extremely remote area that's about 10,600 feet or 3,200 meters above sea level, and where temperatures can drop to as low as negative 112 degrees Fahrenheit or negative 80 degrees Celsius in the winter. This remote location, severe cold, and high altitude make this one of the most difficult places for humans to live on the planet, and it's often called White Mars because of the similarities between Concordia, an important place for studying human psychology and physiology in extreme environments, and offers information that's useful to space agencies. As it offers such a unique opportunity here in Antarctica, the station is used for a wide range of research. One of the main focuses is the climate science, particularly by studying ancient ice cores to understand past climate patterns. By drilling deep into the ice, scientists can extract these ice cores that contain bubbles of ancient air, which then allows them to study the atmospheric composition and greenhouse gas levels from up to 800,000 years ago. Astronomy down here is another focus too, as Concordia's high altitude and dry air provide really clear skies with very little atmospheric distortion. Researchers are therefore able to make astronomical observations that are impossible elsewhere, especially during the polar night when the sun doesn't rise for months and there's a permanent, uninterrupted view of the night sky. Number 14, the Amazon Tall Tower Observatory in Brazil. The Amazon Tall Tower Observatory allows scientists to study the Amazon rainforest's atmosphere, ecosystems, and their effects on global climate from above the forest canopy. Known as the ATO, research at the tower is mainly to study the interactions between the Amazon rainforest and the atmosphere, with an emphasis on greenhouse gases, aerosol particles, and the forest's impact on regional and global climate systems. This is pretty important because the Amazon is the largest tropical rainforest in the world, which covers an area of over 2 million square miles or 5.5 million square kilometers, and its influence on the Earth's climate is huge. It is increasingly important, though, to understand exactly how the rainforest stores carbon, releases it, and interacts with other atmospheric gases, especially as deforestation and rising global temperatures are being seen to affect the stability of the rainforest. ATO's tower reaches above the canopy to gather data on various gases like carbon dioxide, methane, and water vapor, which are the most important ones to monitor to study the Amazon's carbon cycle. The vegetation here and observe natural atmospheric process and how they're changing with the inescapable effects of human activity. Number 13, Scott Base in Antarctica. Scott Base, which is in New Zealand, is the only Antarctic research station. It's on the southern tip of Ross Island, near the western coast of Antarctica's Ross Sea. It was first established in 1957 as part of New Zealand's contribution to the International Geophysical Year, which was a worldwide initiative to further understand the planet. Scott Base has become a focal point for New Zealand's Antarctic scientific research and exploration efforts. It was named after the famous British explorer Robert Falcon Scott, who led expeditions in the region and now assists with polar research and supports international scientific collaborations. The base is on a volcanic island close to the Ross Ice Shelf, which makes it an ideal place for researchers. The facility is made up of a series of interconnected green buildings, which was a purposeful color choice to improve its visibility in the white Antarctic landscape and in the future. With its closeness to the nutrient-rich waters of the Ross Sea, marine biologists often work out of Scott Base as well. The Ross Sea is one of the most pristine marine environments on the planet and was designated as a marine protected area in 2017. Researchers here study the ecosystem beneath the ice, including unique species that have adapted to the extreme cold and darkness. Understanding these ecosystems furthers our understanding of global biodiversity and how life can adapt to some of the planet's harshest conditions. Number 12, the Mauna Loa Observatory in Hawaii. The Mauna Loa Observatory, which is known as MLO for short, is on the Big Island of Hawaii. It's one of the world's leading atmospheric research facilities, and it's dedicated to monitoring and studying global climate change and atmospheric composition. It was built at an elevation of 11,135 feet, or 3,397 meters on the slopes of Mauna Loa, which is one of the world's largest dioxide concentrations, and provided the first evidence that human activities, such as the burning of fossil fuels, were increasing greenhouse gases in the atmosphere. The Keeling curve is now an important measurement in climate science, showing the rise in levels and providing data that shows the importance of addressing climate change. The high-altitude position of MLO has been the main reason why it's been so successful in capturing accurate data. This allows scientists to get a true sense of the composition of the atmosphere, and because of its height, this isn't affected by the lower atmospheric layers. While carbon dioxide measurements is what MLO is most famous for, the observatory does conduct other wide-range atmospheric research. It measures greenhouse gases like methane, nitrous oxide, and CFCs, as well as pollutants like sulfur dioxide and ozone. These gases are monitored all the time, and because it's been going on so long, it's created one of the longest-running atmospheric records available. Things here haven't always been easy though. Because of its isolation on an active volcano, eruptions have occasionally disrupted. It's operated by the British Antarctic Survey, and it's designed to withstand some of the harshest environmental conditions on the planet, with temperatures often plummeting below -58 degrees Fahrenheit or -50 Celsius. Officially, it opened in 2013, and it replaced its predecessor, Halley's 1 to 4, which were gradually abandoned due to the shifting ice. Cleverly, Halley 6 has a modular mobile design, which means that shouldn't be a problem again. This is made up of 8 interconnected modules, each of which is mounted on hydraulic legs with giant skis, and that allows the entire structure to be relocated as the ice shelf moves, which prevents it from becoming trapped in the huge crevasses that open in the ice. Halley 6 is primarily a research station, with a focus on studying atmospheric and climate science, space weather, and glaciology. One of its most important contributions to science is the long-term monitoring of the ozone layer. And it was at Halley Research Station in 1985 that scientists first discovered the hole in the ozone layer, which was such an important discovery that it led to the global power grids. Number 10. The Aquarius Reef Base in Florida. The Aquarius Reef Base, which is around 3.5 miles or 5.4 kilometers off the coast of Key Largo in the Florida Keys National Marine Sanctuary, is the world's only undersea laboratory. Operated by Florida International University, it's 66 feet or 20 meters down below the surface on the ocean floor near Conch Reef, and it's been a center for underwater research and exploration since it was built in 1986. The facility is designed to allow scientists and aquanauts to conduct extended research missions, gathering data on marine life, coral reefs, and ocean ecosystems in ways that are simply not possible from the surface. Coral reefs are some of the most biodiverse habitats on Earth, but they're under severe threat from climate change, pollution, and overfishing. Researchers use data to study the impacts of temperature changes, ocean acidification, and other environmental stressors on coral health, with the ability to monitor the reef ecowork directly on the reef for up to 9 hours a day. Aquarius has been so important in a wide range of scientific studies, from coral biology and ocean acidification to studies on marine animal behavior and ecology. NASA, for example, uses Aquarius for its Extreme Environment Mission Operations program, where the astronauts simulate the condition of space missions, with the underwater environment allowing them to test equipment, practice maneuvering in confined spaces, and work on tasks under conditions that are similar as you can get to the reduced gravity of space while still being on Earth. As for the base itself, the habitat can have up to 6 aquanauts who live in a pressurized tube-like structure with sleeping quarters, a galley, and a lab area. It's anchored to the seafloor and has a wet porch entryway that allows divers to come and go underwater. And as for the importance of studying places like this, it's only increasing. It's seen as a blueprint for several other similar facilities that are now being planned elsewhere around the world. Number 9. The Amundsen Station has, though, undergone several reconstructions since then to withstand the harsh polar conditions, and the current version, which was completed in 2008, is designed to endure some of the coldest temperatures on Earth, where winter temperatures can drop below -100 degrees Fahrenheit or -73 degrees Celsius. The station is named after the explorers Roald Amundsen and Robert Falcon Scott, who led the first expeditions to the South Pole in the early 20th century. Unlike those early explorers who spent months reaching the pole, today's scientists and support staff arrive by plane during the summer months when conditions are a bit better. Between February and October, though winter's extreme cold and constant darkness completely isolate the station, making it inaccessible, even if there's an emergency. Research at the station covers a wide range of areas, but one of the more important is astrophysics. The South Pole Telescope, which is a 33-foot or 10-meter instrument that's installed at the station, studies cosmic microwave background radiation, giving information about the origins of the universe, dark matter, and dulled by the extreme weather. Supplies here are delivered only during the summer months, so the station has to be self-sufficient during the more difficult times, storing food, fuel, and medical supplies for the long winter. These harsh conditions, periods of isolation and confinement make life here at the South Pole psychologically demanding, and those who go there are carefully vetted and selected for their ability to cope with such an environment. Number 8. The Sanford Underground Research Facility in South Dakota. The Sanford Underground Research Facility, which is known as SURF for short, is in Leeds, South Dakota, and it's one of the world's most advanced underground laboratories. It's dedicated to research in particle physics, astrophysics, biology, and geology, and it's in the former Homestake gold mine, and is more than a mile below the Earth's surface, where scientists can set up sensitive experiments that require shielding from cosmic radiation. Since opening in 2007, SURF has become an important part of several groundbreaking scientific projects, with some of the most ambitious experiments that are aimed at exploring fun and cosmic rays. One of SURF's most important experiments is the Lux-Zeppelin dark matter experiment, which is at the 4,800-foot or 1.5-kilometer level of the mine. Dark matter, which makes up an estimated 85% of the universe's total mass, has yet to be directly observed, with scientists believing it interacts so weakly with regular matter that it passes through most detectors without a trace. The LZ experiment uses a huge tank filled with liquid xenon, which has been cooled to extremely low temperatures to create a detector that's capable of capturing the rare interactions. The extreme depth of the mine provides a shield against most background radiation, allowing scientists to focus on any potential dark matter interactions. SURF is also the planned site for the Long Baseline Neutrino Facility and Deep Underground Neutrino Experiment. Now, these projects involve a collaboration between SURF and Fermilab in Illinois, where there's a high-energy beam of neutrinos that will be generated and sent 800 miles or 1,300 kilometers of life on Earth, and also the potential for life in extreme environments on other planets. Moving on to number 7, the Neumayer Station 3 in Antarctica. Neumayer Station 3, which is on the Ekstrom ice shelf in Antarctica, is Germany's cutting-edge polar research station. It opened in 2003. Neumayer 3 is unique for its design and technological advancements that allow it to withstand the harsh environment while supporting year-round scientific research. To do this, it has an elevated design which sets it apart from other Antarctic stations. The station is on a platform that's supported by 16 hydraulic stilts, which can be adjusted to keep the structure above the snow. Each year, the stilts are raised to compensate for the annual snow accumulation, allowing Neumayer 3 to avoid being buried. This means that the station should be able to remain operational for decades in one of the most inhospitable environments. The station is an interdisciplinary research hub that hosts scientists from around the world who conduct studies in various Arctic ice sheet. Equipped with advanced instruments, researchers continuously monitor greenhouse gases, ozone levels, and aerosols, which improve our knowledge of the interactions between the Antarctic atmosphere and worldwide climate systems, particularly as the southern hemisphere's climate patterns have influential effects on global weather and ocean circulation. Marine biologists here study the unique ecosystems beneath the ice, including species that have adapted to the near-freezing water and long periods of darkness. It's research that, again, helps us more fully understand the biodiversity in extreme environments on our own planet, but can also reveal clues about where to look elsewhere in our solar system for extraterrestrial life. Number 6. Summit Camp, Greenland. Summit Camp is a research station that's at the highest point of the Greenland ice sheet, at a height of about 10,500 feet or 3,200 meters above sea level. It's close to the middle of the ice sheet, and it's been operated by the U.S. National Science Foundation since it was opened. The big focus at the facility is, of course, climate science, particularly the study of ice cores, which are drilled deep from within the ice sheet. Summit Camp is also a place for atmospheric research, with projects focused on tracking greenhouse gas, aerosol particles, and other chemicals that influence the climate, and instruments here measure the levels of carbon dioxide, methane, and other pollutants, as well as lesser-known compounds like perfluorinated chemicals, which are found in industrial products. Because Summit Camp is so far from urban centers, it provides a baseline atmosphere that's relatively free from human contamination, allowing scientists to study natural atmospheric processes and how they're affected by global pollution. It's far from easy work there, though, as due to its high elevation and location on the sheet, the camp experiences some of the harshest weather conditions on the planet. Strong winds, freezing cold temperatures. Winter temperatures can plummet below -76 degrees Fahrenheit or -60 degrees Celsius, and strong winds create an unforgiving wind chill. The station operates all through the year. Polar station on either end of the world that's powered entirely by renewable energy. Positioned at an elevation of 4,600 feet or 1,400 meters on a rocky ridge that's free of ice and snow, Princess Elizabeth Antarctica has a stable foundation that offers protection from the moving and accumulating ice. The location here provides a clear place for studying climate patterns, glaciers, and ice sheets, which are vital for understanding the impacts of climate change. The station operates mainly during the Antarctic summer, from November to February, when the extreme temperatures are more manageable, but thanks to its energy-efficient design, it remains functional all year round. The station's equipped with a hybrid energy system that combines wind and solar power, taking advantage of the constant sunlight during the summer and the strong winds typical of the region. Excess energy is stored in a battery system that can provide power during cloudy or low-wind periods, and this gives a reliable, consistent energy supply without fossil fuels. In addition to renewable energy, the station uses advanced water recycling and waste management atmospheric science. The station's remote location and environment provide an ideal setting for climate research, and the researchers at the station study ice cores, which hold historical climate records and analyze atmospheric gases. The station does also support studies on microbial life in extreme conditions, offering insights into how life might exist in similarly harsh environments. Number 4. The International Space Station in low Earth orbit. The International Space Station, the ISS, which orbits the Earth at an altitude of about 248 miles, or about 400 kilometers in low Earth orbit, is the most ambitious project that's ever been undertaken. It was a joint venture between 5 space agencies: the United States' NASA, Russia's Roscosmos, Japan's JAXA, Europeans' ESA, and Canada's CSA. The ISS has been continuously occupied by astronauts ever since November of 2000. The station is made up of a series of interconnected modules, each with a specific function. There are, for example, living quarters, laboratories, sunrises, and sunsets each day. Research on the ISS has had far-reaching impacts on Earth. The station's microgravity allows scientists to study biological and physical processes in a way that are impossible on Earth. So, for example, experiments on muscle atrophy, bone density loss, and fluid shifts in the human body help scientists understand the effects of long-term spaceflight. Research on plant growth in space has also helped in developing sustainable food sources for future space missions, as well as improving agricultural techniques back home. Life on the ISS is a constant balancing act between research, maintenance, and adaptation to the unique environment of space. Astronauts, they live in confined quarters and have structured daily schedules, sharing their time between scientific work, physical exercise to combat the effects of microgravity, and daily tasks to keep the station operational. Communication with Earth is maintained through NASA's tracking and data relay satellites, which allow the crew members to connect with mission control and family, although they experience a level of isolation from it. And it was first built in 1989 as a summer-only research outpost, but has since been expanded to year-round operations since 2005. This development allowed Norway to improve its role in Antarctic research and environmental monitoring, and the station's become a crucial place for scientific studies. Troll Station is designed to host up to 40 researchers and support staff during the summer months, though the population is reduced to around 6 to 10 people in winter, who stay for extended periods in isolation. The station's operations means that Norway can monitor Antarctic conditions continuously, which is essential for climate research. There is a huge commitment to sustainability at the station too, and in 2007 Norway built a wind farm to provide the station with renewable energy and to reduce its dependence on diesel fuel. These wind turbines, combined with some solar panels and efficient power management systems, allow Troll Station to operate with a significantly lower carbon footprint. And the station uses advanced waste treatment systems to manage human and scientific waste, with most being transported back to Norway. Studies monitor ice sheet dynamics and the stability of nearby glaciers. Researchers study snow accumulation, melting rates, and glacial movement, tracking how the ice sheet responds to global warming. By understanding the composition and behavior of the atmosphere in such an environment far from human civilization, scientists can learn far more about how human activity affects even the remote regions on Earth. Number 2. The China Jinping Underground Lab in Sichuan, China. The Jinping Underground Laboratory in the Sichuan province in China is the deepest and most advanced facility in the world for underground scientific research. It's beneath Jinping Mountain and accessed through a 10-mile or 17.5-kilometer tunnel system, which leads to the laboratory that's buried about 7,900 feet down, or about 2,400 meters. This depth provides the perfect environment for highly sensitive scientific experiments that require as little interference from cosmic radiation as possible. Now, the lab's location near the Jinping hydropower station is known, and perhaps weakly through other fundamental forces. The dark matter experiments down there, such as the China Dark Matter Experiment and the Panda X project, use ultra-sensitive detectors that are designed to capture rare interactions between dark matter particles and atomic nuclei. Beyond the dark matter, though, CJPL is also used for research in neutrino physics, nuclear astrophysics, and geophysics. Neutrino studies here explore those particles, which pass through matter almost undetected and are really challenging to study. Research into these neutrinos may help answer fundamental questions about the universe's formation and the nature of matter, and it's in the laboratory shielding from cosmic rays that make it one of the best locations in the world for that type of study. It is a similar case for experiments that study the rare radioactive decay too, which provide insights into fundamental symmetries in physics. Now, those experiments often require long-duration measurements with an environment free from radioactive contaminants and cosmic interference. The lab also offers an isolated environment for study near the Ross Ice Shelf, about 840 miles from South Pole. First built in 1955, the station has grown significantly over the decades, becoming a small, fully functional town capable of housing up to 1,200 people. With extensive infrastructure, such as dormitories, laboratories, dining facilities, workshops, and even a post office and fire station, this whole station covers an area of around a square mile, or 2.5 square kilometers, and has more than 100 buildings. The nearby airfield, with a variety of landing strips on both ice and gravel, allows large transport craft to bring in supplies, researchers, and support personnel. Research here at McMurdo covers many different fields, with a particular emphasis on environmental science, glaciology, marine biology, and space science. The ice sheets here in Antarctica are among the most influential in global climate science, so researchers here at McMurdo monitor changes in the ice to understand the effects of any global warming. The Ross Ice Shelf, which is one of the largest floating ice bodies on Earth, is